Okay, should we, well, should we start? Soft voice. Okay, are you ready? Yes. Welcome. I'm that guy, and today I'm gonna make you all work. We are going to write an application here. Um, so initially, I thought this was gonna be a, uh, a lab where you will type the code, and with so many people, I was surprised that so many people signed up. So I decided to save you from the typing. You're not going to be typing a lot, maybe a little bit, uh, but I'll explain how things will work in a minute. So basically, this is me. Right now, I work in OpenStack for Rackspace, and you probably know that I have a blog and I write mostly about Flask related topics. And I have Flask extensions and I have the book, right? Which is almost a year old now. It was almost out last PyCon. It was probably a couple weeks till it released, so almost a year old. So this is what we are going to do today, uh, essentially. I'm going to cover a little bit of what Flask is, but I'm sure you know already, so I'm not going to spend a lot of time there. I'm going to explain the setup in case some of you haven't read my email from maybe 10 days ago, a week ago, and you're not ready. Those are not ready, they can discreetly prepare for this while I demonstrate the final application that hopefully you all going to have running on your laptops today. And then we're going to jump right into it. And I divided this application, which is a basic application, uh, but nonetheless, it uses a lot of the core techniques that you will use on more complex applications. So I divided it in 5 content areas, and there are a few versions of the application. This is one application that we are going to incrementally build, and on each of these 5 topics, we have 2 or 3 stops where we're going to be incrementing, improving the application. And then at the end, if there is time, this is really hard. I mean, this is a beginning class, so I don't know how long it's going to take. I want to make sure that you all get the application running. So there's sort of a, at the end, if there's time, I hope there's time, we can talk about what's next. How do you continue on your learning path, and have prepared a list of topics that we can discuss. At any time, please interrupt me if there's anything that you need clarification on. Um, Teaching a beginner class is hard, I think. I'm not sure that I am not making assumptions, right? So by any means, stop me if there's anything that you think I forgot to explain. I really want to cover everything, and if we need to sacrifice content from the end, so be it. That's fine. I think it's more important that you don't have any holes when you are building this application. So I expect you to interrupt me if there's anything that you think I missed. So Flask. I don't think I need to sell you Flask. I mean, you're here, so obviously you like it. But what I think Flask is good for is for people who wants to do things their own way. Flask is very good at not interfering with your work. You can do things your way, and Flask tags along just fine. It has very little restrictions, so you can pick the tools that you want, and Flask plays along well with them. You can extend it. There are already a number of extensions, and if you don't find an extension, you can build your own. It's very easy. So anyway, I don't think I need to discuss Flask more than this, but if you have any questions, general questions about Flask, this is the time. So Okay? Flask is sold. Okay, so this is a hands-on class. You are all hopefully going to work along with me. I'm going to work too. I'm going to do the same thing that you need to do so that you can see me and then you copy me. So you need a Python interpreter, so hopefully you all have it installed. And I recommend 3.4, but I'm sure some of you have 2.7, and that's fine. If you have Python 2.7, you need to have virtual environments, which they install separately for 2.7. So those of you that have 2.7, make sure you have a virtual env installed. Okay? You need Git because we're going to clone a GitHub repository. And then you need to get the code. And this is how I decided to do this, to save you from the typing part, because I think with so many people, it's going to be very hard. People make typos, and if I need to help, with little typos here and there, we're going to waste a lot of time. So I did the typing myself, and it's all in this GitHub repository that in a minute I'm going to clone. I'm going to show you how to clone it. If you received my email from a week ago, you know already how to, and you probably did it. But if not, you can do it with me in a minute. So what I did with this repository is to create. So I use Git in a way that most people don't use it, and I did the same in my book. Basically, Git has this feature that allows you to rewrite the history. You can clean it up, and that's the main purpose of it. But I use it to create the incremental versions. So as you move along with these version tags, I'm going to show you how to do this. We're going to go to version 0.1, and that's a basic application. Then we move to 0.2, and that adds a few new things. And we keep going like that until we are going to arrive at the final version. So that is how this is going to work. And if you don't understand, that's fine, because I'm going to do it here, and you will see me do it. So, okay. If you think you're not ready, with these requirements, I think it will be good while I do the demo that you get whatever you don't have from here set up, so that you're ready to begin in a couple minutes. So the application that we are doing today, it's a simple game that's called Guess the Language. You may have seen different versions of this with animals. It's typically the way they do this. So basically, this is a game application, and it's going to try to guess the language. So we need to think of a language. I don't know which. Let's do Python. So it's going to ask me questions. So is it interpreted? Python is interpreted. So I'm going to say yes. And it made a guess, and it guessed. So I'm going to say that this was right, and the game begins again. So let's say, let's go with Ruby. So I'm going to say it's interpreted, yes. It's going to guess Python again, so it didn't know about Ruby. So I say no. And now it wants to learn this new language that I picked. So I picked Ruby, and now it wants a question that can differentiate the guess that the application made versus my guess. So I'm going to say, does it enforce indentation? That's a question that could tell these two apart. And for Ruby, the answer will be no. Okay, so when I play again, I say that it is interpreted, and now it incorporated the new question. Okay, and it keeps learning, and it adds more languages as it plays. So this is the application that we are building here today, and we're going to go little steps until we arrive at the final version. Okay, you think you're all ready to? You have all the software ready? Uh, are any of you running Windows and Python 2.7? You are? No? Okay, good. So yeah, the only reason I ask is virtual environments are a little bit harder to install on Windows for 2.7. So I just want to make sure that that we're good there. Okay. So we are going to begin by cloning the repository. So when you're working on your own with your own projects, this step will be creating a project directory, an empty project directory where you will write your application. So in place of that, to save you from the typing, we are going to use the GitHub repository. So I'm going to go ahead. I'm going to go. So I learned my shortcuts here to go to the different screens. I hope I don't mess up. Um, I go to my terminal. So this is what I was demoing today. So I'm going to stop this. And I'm going to clean up this screen. Go to my home directory. So hopefully you are in a directory. So now I'm going to clone the project. So most of you, if you read my email, you have done this already. Okay? So you can CD into it. In case my prompt confuses you, this is a fancy prompt that shows me the Git branch and the directory where I'm in. So master is the branch. There's no magic there, and it has nothing to do with the project. Don't get worried by that. So do you all have the project? Good. So the next step, you will also do this step when you work on your own projects, is to make a virtual environment. And this is different when you use Python 2.7 versus Python 3.4. So I'm going to show you both ways. For those of you that are running 2.7, you are going to make sure that you CD into the project directory. And well, actually, you can put the virtual environment anywhere you want. I like to put them inside the project, but you don't have to if you don't want to. So you are going to say virtual env and then the name of the virtual environment. So this is the command for Python 2.7. And this will create a private copy of Python in a directory named venv. You can call it whatever you want. I'm used to do it this way. For every project that I have, I create a venv folder or virtual environment inside it. So I know that they're all called the same and they are in each project. But that's my convention. You don't have to follow it if you don't want to. So this creates a private copy of Python where you can install stuff, and it doesn't affect your global Python interpreter. So if you make a mistake, if you install something wrong, if something doesn't work, you can throw away this folder that will be created and then make it anew. Just make a new one, and you're good to go. So okay, this is for 2.7. If you are using 3.4, you are going to do Python. So this depends on how you install 3.4. It may be called Python 3.4. It may be called Python 3, or it may be called Python. And you can find out if you do. So see, if I say Python here, I have 2.7. if I say 3.4, I have both installed. So 3.4, that's my version. So I'm going to call it 3.4. It may not be exactly the same for you. So -m to run the VM package. So this will tell Python 3.4 to run the virtual environment, the native virtual environments that come with it in the library. And then I need to give it the name, and I use VM as name. So there are two VMs there that have different meaning. Hopefully that's clear. So I'm going to run this one to create the virtual environment. So now there is my my folder. You should see this regardless of if you use 2.7 or 3.4. So okay, the next step is to start using the Python that is in the virtual environment versus the global Python. There are a couple ways to go about this. So what I'm going to do is this action that's called activating the virtual environment. And for that, on Linux and Mac, you need to source a file that basically changes your path so that when you say Python, note that I don't have to say 3.4 anymore because now the path has been modified so that the Python that is in the virtual environment is now in my path. So that's the one that comes up when I say just Python. So some of you are on Windows, I assume. Do we have Windows people? Yes. So on Windows, it doesn't work this way. On Windows, you need to say, I'm going to show you with the backslash. That's what you need to say on Windows to achieve the same thing. And give it a try. Make sure that that it works for you. You know that another way to know that the virtual environment has been activated is this thing that it adds to the prompt. That should do it on Windows too. Yes? Are we all good? Yes, good. Okay. Yes.
I'm having a hard time getting the clone into the virtual environment right now.
Um,
I must be typing something wrong.
so you cloned before class, right? So you have the files.
Yeah, but I had it in the non-virtual environment because
Yeah.
I don't have the one set up, and I was having a hard time doing it right now. So I'm working with my 2.7.
Okay.
And the virtual environment with 2.7. I was having a hard time bringing the clone of the repository into my virtual environment.
It's the other way around. When so you have your cloned project, you cd inside that main folder, and then you create a virtual environment inside it. So cd. Another question? I can hear you. Sorry. So you have 2.7 and virtual envs installed? It's fine. I mean, I use 3.4 because that's the current version, but I made sure that everything works the same on 2.7. So I don't worry about it. It's fine. You think we're ready to go to the next step? No more questions? So the next step is to install Flask in the virtual environment. So for this, we use pip, the Python installer. So the way you do this, and this is the same for everyone. So 2734, Windows, non-Windows, they're all the same. Pip install Flask. And this will bring Flask and a few dependencies that Flask uses. So go ahead and do this. Anytime you work on your own projects, you will be doing the same thing. You will create the project and then create a virtual environment and then install Flask in it. So this applies to your own projects as well. No problems? Please stop me if you're not. Okay, I have to assume that you're good. So, okay, we are going to start with a very simple application. As I said before, we are going to build this little game application one step at a time. So we're going to start with something very simple, which is to show the title in the web browser. So remember that I mentioned that I have all the incremental versions of this application as tags, v0.1, 0.2, and so on. So this is v0.1. So inside the Git repository folder, you can say git checkout v0.1, and this will sync the files in that project to the first version, which I labeled it simple application. And I want to repeat this. This is unusual when you work on your own projects. You don't have any of this. This is me saving you from typing all the versions, right? This will create the application so that you don't have to type it. So if you get a directory listing now, the only Python file you see it's a very tiny file called app.py. So let me show you this file. I'm going to show you the file, explain it, and then we are all going to run it, make sure that it works. So I'm going to go ahead and open the file in my text editor. So it's a very simple file, short. So this version of the application, the only thing it does, when you connect to the web application, it will show the title, which was guess the language. That's all it does. So I'm going to start with this function. There's just one function in the file. I called it index because it's the main entry point of the application. But this is just a name. It can be any name you want. This is another convention that I have. I tend to call the main page index. So what we want is for this function to return what goes in the browser, the title. So what I did is I just return the HTML for a title as a string, okay? And note that this is really it's not proper HTML. For now, we're going very simple. We're just putting the H1. A proper HTML page will have other stuff in it, and we are going to see that in a minute. For now, let's do a simple string. And I'm taking advantage that browsers are very permissive. They allow this. So if you give a browser this, it will assume all the missing stuff and it will show you the content. So for now, I'm going to take advantage of that and simplify this. I need to tell Flask that I want this to be the root URL of my application. I need to connect this with the URL that the user types in the web browser. And that is done this way using a decorator. Um, so you may or may not be familiar with this. This is a Python feature. If you prepend a function with something that starts with the @ sign, that's called a decorator. What that does is to modify the function in different ways. In this case, this app.route decorator will create a mapping between a URL and a function. So I'm saying that the root URL of my web application is mapped to this function. So then Flask now knows that when someone types the root URL in the browser, then Flask needs to run this function. That's all it does. Okay? So Flask runs its function, and it collects the return value, and then gives that to the browser. It's super simple. But this is very important. This is the core technique that you use when you write web applications. Basically, the browser sends a request with a URL. Flask looks at the URL, finds which is the function that's associated with that URL and runs it, collects the response, and sends that back to the browser. Does that make sense? There's a little bit of boilerplate that you need to add for this to work. Flask needs an object that represents the application, and that's from where I get this app.route decorator that maps URLs to functions. So that's here. It's an object of class Flask with uppercase F, which I import from the Flask package, which uses lowercase f. A lot of people find this confusing. When you create a Flask application, Flask needs to know where your files are. And right now, this application is very simple. There's no other files besides this script. But later, we're going to have other files, and Flask needs to know how to find them. By passing this, which is in Python, this is a Python variable that is the name of the module that's running, the name of this module. Flask uses that to find where this module is, and then the other files, which are located in a relative location from this file. This at the bottom is the way we start the application. So when you create a web application, there are basically two components. You have the web application itself, and then you need a web server. The web server is the networking component that is listening for requests coming from clients, from browsers or other clients. They're separate. And in Python, there's a very well-defined structure for web applications and web servers. When you are developing, Flask comes with a web server that can simplify the setup so that you can right ahead go and work with your application. And to start that web server that comes with Flask, you invoke a function called app.run. And then you can pass a number of arguments, and one of them is debug true, which will enable debug mode. And we're going to see what that means. So don't worry about it for now. We're going to play with this later. If you don't know what this is, if you don't put this, everything will work just fine. So you could say, you do it like that, and it will work, no problem. The problem when you do it that way is that sometimes you need this file to not be the main file that you run. If you imagine that eventually this will be the full application and you are going to deploy it to a production server, and when you do that, you're not going to use the Flask web server because this is not performant enough. It's not really good for a production environment. It's very good. It's awesome for development, but not good for production. So if you put this without this conditional, that means that when the real web server tries to run this file, the Flask web server will run as well, and we don't want that. So this conditional is a nice way to separate the cases where you run this file as the main file versus when you run this file from another file. So when this is a secondary module, the web server is not going to run, essentially. Does that make sense? Okay. And well, I guess I didn't explain this line here. So this is a Unix thing. So for Windows, this is nothing. It's just a comment. For Macs and Linux, this basically tells which is the interpreter that you want to run with this script. It's optional. You don't have to put it there, but since I'm on a Mac, it makes sense to do this. So let's go and run this, okay? So we have app.py. You should all have it. So if you say, oops, Python app.py, which basically we run this file as a regular Python script. And you should get that message. The message is saying that the application is now, or I should say the web server is listening on that address. You can take that and copy it and then go to, so this I'm going to stop. This was the demo that we did earlier, so I'm going to clean that. So if I paste here that address that Flask gave me, I get the title. So make sure you get this working. If this doesn't work, then nothing else will later. So make sure that this works. No questions? Yes.
I'm sorry, but I'm not, I only have my stuff put together.
Uh,
Maybe I need to take stuff out of it. Can't import that file that you had.
did you do the git checkout command? You had the project clone, so git checkout v0.1. That should bring your that should sync your application to the first version.
I'm having a problem with the IP address. It's 0000. I'm running in a virtual machine.
0000 is fine. It will still work. I'm going to cover what's the difference in a couple minutes, actually. We're talking about that. One more. Yes. Okay, so you have trouble getting into your virtual environment. What does that mean? Did you activate it? Did you do the... So you are on a Mac. So that's the command that you need to run at the bottom. Source vm/bin/activate. Everybody else fine? Good. What we can do during the break, anybody that has problems, we have 20 minutes of a break. I'm happy to repeat whatever is necessary and fix whatever problems we have. Okay? Okay, so we were running and connecting to that address gives you this string that we have in our function. Yes? So if you are able to get this, now we're ready to add a little bit to this. Just make it a little bit more interesting. Okay. So in version 0.2, I have added a little thing that's a very important technique that I use a lot when I work on much more complex applications. So let's look at that. So you're running the first version. You can hit Control C to stop it, and then let's check out version 0.2. One thing I probably need to mention: if you edited the file, this app.py file from v0.1, when you try to do 0.2, Git will say no, because it will think that Git doesn't want to delete your changes. If you modified it from the way I have it in the repository, then Git will refuse to switch to a different version so that you don't lose your changes. So if any of you have that problem and want to undo that, the easiest way will be to undo the change that you've made. If you don't remember, then there's a magic command from Git that will erase any changes. So ask me. Okay, version 0.2. Let me show you the new version. So what I did here is I left the index function the same. I didn't change that. But I added a second function. This is if you remember the demo that I did earlier, this is the function that shows the final guess, the beginning of that function. It's not complete yet. So this function shows a title, and then it shows a guess, which I put in a p HTML block, p as a paragraph element. And for this, I have to get a little bit, this is a little bit more involved. I wanted to show a real thing here, something that is not hard-coded text. So what I did, and this is the important technique I mentioned before, that I use all the time. I created a mock object here. So this is a collection of guesses. For now, it's just a list. It's not going to stay this way later. But when you're starting to build an application, there are so many things that you need in place that if you try to get all of them done, then it's impossible. It's really hard. So you have to concentrate on one thing and then fake the rest. And this is the way to fake not having a game, right? We don't have the game logic yet. So I just have a list of possible answers or guesses. And I use the templating support in Python to insert a guess here. Now, how do I know which guess? I want that to be, for now, part of the URL. So take a look at how I did the routing for this function. I have slash guess slash, and then I have a dynamic component. So when Flask receives a URL that's slash guess slash, and then an integer, I'm giving a type here, so this is going to be an integer. So for example, slash guess slash 0. And then Flask will map it to this function, and it will send me the number, whatever the client typed in that URL, as the ID argument here, so that I can use it. So I use it to index my mock list of guesses. So if I say slash guess slash 0, that will be guesses 0, which is Python. Something very important to mention here is that this is something that comes from the client. A user is typing this, and users are untrusted. So this is temporary. I want to make sure, I'm sure some of you at least already know how to break this application. It's very easy to break this application, yes? Right? If you say slash guess slash 124, that's going to break, right? It's going to crash. So anytime you receive input from users, the input needs to be validated. I'm not doing that here. We're going to do it later. So don't let you distract you from, don't let that distract you from the actual content of this part. We are going to look at validating user input later. So okay, so I can run this again, same as before. And if I type this URL, same thing. I didn't change that. But if I say guess 0, and if I say guess 1, and I have guess 2, and remember what I said about crashing the app? Let's try it, just for fun. Okay, so this, to some of you, might look very confusing. This is a debugger. We're going to look at it a little bit later, so don't worry about it for now. This is one of the things that you get when you run Flask in debug mode. Remember that I enabled debug mode? So this is super useful when you have a bug in your application, and we do have one now. So we're going to look at this later. Are there any questions so far? Is it clear that this is how you can have data in the URL? Let me give you a useful example. When you go to your like your Twitter user page or Facebook user page, you'll probably notice that it's facebook.com/ and then your name, right? So this is how you do that in an application where you have a profile page. You can have with Flask, you can have the username in the URL, and this is the technique that you use to get it. Okay. So one more little change here. This is something that I did not consider important, but a few times I spoke and people asked this, so I decided to include it. You probably get your first application going, and you probably want to show it like to your family or something, and you're going to notice that with this version, if you have the server running on your machine, you try to connect from another machine and it's not going to work, except for you. It's not going to work because the address Where is the address where this address is localhost. This is the address of your own machine. That means that Flask is only listening for connections from your own machine. So if you want to have this as a proper web application, web server that can be contacted by others, except you already have it, but you need to change this. You need to tell Flask that you want the web server to listen on the public network interfaces on your machine. And in version 0.3, I added that. It's a very simple change. You can see it here. When you run the development web server, if you tell it that you want the host to be 0000, that will make Flask listen on the public Ethernet of your machine or Wi-Fi. It's actually all the network interfaces in your machine will be listening for connections. If you wanted for some reason to listen on one of them, if you have multiple, like I have two here, so if I wanted to listen on one, I could put the IP address of that one. But if you say zero, all zeros, then it listens on all of them. So now, if you have a network in your home, then you can contact the application from the other machines in your network. The second argument, port. I don't know if you know this, but when you make a network connection to a machine, you have to say which port you want to connect to. And in Flask, the default port is 5000. When you connect to a regular application on the web, you don't specify a port number, but there's a default, and the default is number 80. So you always have to say which number. So I kept it at 5000 for this application, but you can change it. It's really, it could be any number. Some of the ports are reserved for administrators. These are the ports below 1024. So if you wanted to run on port 80, you need to have administration rights. You need to run this under an administrator account. So there's really no difference here, so I'm not going to run this. The only difference is that the application is now public. You can reach it from outside your own machine. So this is all I have for the most basic part of the class. I'm ready to move to the next topic. So if you have questions, this is the time.
Not important, but I'm curious. So if I try to go to open up, port 5000, it says, cool, let's strip root over that, and doesn't actually get that.
Did you? What did you type?
Just that address.
She navigated to it.
Yeah, HTTP.
You want to go to localhost still, because that's still the hosting you're trying to reach. 000 just says to
Oh, did you type? So 0000 is not a real address. That's how you tell Flask that you want to listen on the real address. Okay, good. Any more questions? I didn't mention this, but this interaction requests and responses, that's how most web applications work, the real ones. So really, what I showed you, this interaction where the browser sends a request, and then we run a function that produces a response. That's all there is to it. That's HTTP. So Facebook, that's all they do. They send requests, and then we send requests from our browsers, and they respond. There's nothing else. I mean, the rest is all stuff that happens in your machine with JavaScript and on their servers with whatever they use. But the communication is just HTTP. Twitter, same thing. So, I mean, once you understand this, basically you have the tools to write big applications. This is not the only way to have a client communicate with a server, but it's the way that most applications use. So the next topic is templates. So what's the problem? Did you notice in my, I don't know if you agree, this is kind of ugly. Yes? Imagine, I mean, the application will continue to grow. We're going to have, if we wanted to do it properly, we need to have a full HTML page with all the extra, HTML headers and elements that need to go in there. So that's going to be a long string. And if you are doing something more complex, maybe showing a table with data, it's going to be awful to have to create strings that then insert dynamic data in the middle. So nobody does this, right? This is only for very simple tests, quick and dirty. But for real stuff, you have to find something that's more maintainable. Okay? So what we are going to do is to use templates. And a template, it's basically a file, separate file from this, that contains the response that you want to send back to the browser. So you put it in a separate file. In this case, we have two routes here, right? The one that shows the title and the one that shows the guess. So we are going to create two templates, one for each, and that's how you do it. You create one template for each type of response, each page, if you will, that you want to send to the browser. So version 0.4 is the one that does that. And after you do git checkout v0.4, that's going to add a templates folder with these two templates. So let's look at the easy one. So here, now I have a standalone file, so I can be more HTML correct here. So I created a full HTML page. So I have a title. This will show in the title bar of your browser window. And then in the body, I have the H1 element that we had before. And since this is so easy, I added some more content. So I just added the introduction. And I don't know if you remember from the demo, the first page explained what was going to happen, and then it had a click here to begin. So I added that. This is in HTML. This is how you do a link, but we don't know how to do links yet. So the link is not functional yet. So we're going to try this, and clicking there, it's not going to work yet. But at least we have the link in place. I mean, the point is, now that we have a standalone file, it's so easy to make this look better. And one thing that a lot of people do is you have developers that develop the code, and you have designers that design the pages. So when you have this separation, you can give your designer friend, your web designer friend this, and then it can be transformed into something that looks much better than this. You can use a framework like Twitter Bootstrap that will give you a very nice HTML page. And if you're not the one that does that work, you can send it to someone who knows how to do that. And then when you receive the template, you just drop it in place, and you don't have to change the application. It's completely separate. It's they're decoupled, which is good. So I have the HTML code for that index page in a file, and now I need to tell Flask to use that instead of a string. So I replaced the hard-coded string with this function, which comes, it comes here. I have it up here. It's imported from the Flask module. And this will go look, and this is all running with defaults. So Flask, if you don't tell it otherwise, it will go look for templates in the same location where your script is. It will look for a template folder there, and then it will look for templates inside that folder. So I say render template index.html, and then Flask will go read that file and send it to the browser. The second one is a little bit more involved because you remember we had a dynamic component there. So we need to somehow insert that, whichever of these elements that are selected in the template. And this is how you do it. You use this double curly bracket syntax in the template to say that's a placeholder. You want to insert a variable there. That's called guess in this case. And in the code, you have to pass a value for that as an extra argument to render template. So render template not only reads a template file, it then replaces any placeholders in it before it sends the final rendered version to the browser. So when I run this version, oops. So now I get slightly nicer HTML. At least this is a complete page. And as I said before, this link is broken right now. Doesn't do anything yet. And if I go to the other one, that it's pretty much the same. This one is no different than the previous one, but at least we have a platform where we can make this page more complex, being in a standalone file. Are we all good so far? Something that's very common, all applications do this, is they link pages, right? That's what, when you're in a web application, you're basically clicking links and going from one page to another. So we need a way to link pages. So let's look at that non-functional link that I have in the main page and see how can we make it work. The straightforward way to do this will be to just go to the template, and right there, in the same way I'm typing URLs in the address bar of my browser, I can just type a URL here. I can make it slash. Well, we don't have too many options now, but let's say I could do this, and it will work just fine. The problem is that if I do it this way, this syntax /guess/number is now in two places. I have it here, and then I have it in the up route here, right? So I have it in two places. If I need to change it, I'm going to have to remember to change it in both, right? And when the application grows, it's going to be in even more places. And then I may forget to change one, and then you get a bug. So it would be better if you had this in one place, So when you change it, all the other places update on their own. And Flask provides a way to do that. So let's go to version 5. And if you look at this one, oh, what happened here? Sorry. Oh, right, I modified it. Well, what I tell you, you shouldn't do, I did. Nice. Okay, sorry. I'm going to use that magic trick. I'm going to reset everything. There you go. Okay. Flask provides this function. It's called URL4, and it uses it to generate URLs using all what it knows about the URLs in your application. So all those app.route decorators that you put in your routes, Flask uses them to build a database of a mapping between routes and functions. So Flask can use it in the reverse way. It can go from function to URL and generate the URLs for you. And that's what URL4 does. So I give it the function name and any arguments, and it generates the URL for me. And note that I put it in a double curly bracket because this is a variable as well. So inside curly brackets in the templates, which by the way, I didn't mention this, the template engine that we're using, that Flask uses, it's called Jinja 2. So in Jinja 2, the curly brackets, what you put inside could be a function as well. It doesn't need to be just a plain variable. So I call this function, and the return value of the function will be what gets replaced in that place of the template. So I'm using here a function name. We don't know this one. This is a new one. I introduced it in this version. When we click on this one, we need to go to the first question. So I put a question route. So now this version has 3 routes. So we have the index, question, and guess. So when I say URL4 question, that's the question name that Flask will look up, and then it will find that that function name is associated with this URL. So then URL4 will return this URL. Now this URL takes an argument, so I need to give that argument as well. So you saw it here that I have, in this case, I put 0 for now. And that will go to the first question. Now, this is the template for the question. We didn't have this before. This one has a title, the text of the question, which is a variable. And if you remember, the question pages had a click here to end the game if you wanted to abort the game and go back to the main page, the index page. So now this is easy to implement. I say URL4 index, and that goes to the main page. And here we have the 3 routes now. So if we run this version, shortcuts are driving me crazy, sorry. Oh, I'm sorry. I didn't show you the. Sorry, this. I added fake questions as well that the question page returns in the same way that we have the guesses. This is all fake for now. We don't have a real game yet. So I don't know if you can see it at the bottom. It generated the URL for me. I didn't have to hard code the URL. So when you do it this way using URL for, the only if you want to reorganize the URLs in your application, all you need to do is just change them in the one place they exist, and they get updated on their own. So I strongly recommend that you don't hard code your URLs because you forget about them. Yes.
Bases it on the function name.
Yes.
So if you change the function name, you have to.
If you change the function name, you have to yes, you have to do that. But that's a lot easier to search for. You can search for this as a string, and you're going to find all of them pretty easily. Maybe you find more than the ones that you need to change, but at least you'll find them. Um, and I don't know if you really care about details. The fact that it uses the function name as the default, you could use a different name. I never do it. It's awfully confusing. But you can specify. I don't remember exactly. I think you say here, endpoint. And you give it a different name if you want. Um, okay. So, any questions about links? Yes. Yes. You have some restrictions. Normally, you can use variables. You can configure the template engine to recognize some functions, and Flask configures URL4 and a bunch of others for you. You can define your own functions to be there. You can pass a function in the. What did I do here? I'm sorry. What? I'm sorry. I don't know what I did. I think I went to the last version of this. Hold on one second. What? What's going on?
You have unsaved changes.
Here we go. I think I had open. I think I did one extra undo. I had it open, the final version. I'm sorry. Anyway, so here I'm passing strings as arguments to the render template. You can pass a function and then run it. So yeah, there are many ways. I will probably not do this this way. I will register whatever functions you want, with Jinja, and then be able to use them. Many extensions for Flask add things that you can call in Jinja, so it's a pretty common thing and easy to do. Any other questions? Yes. If there's any way to, I don't think there's. So the question is if there's a way to find out what's registered with Jinja. There's probably a way using the Jinja internals. I don't think there's an API to get a list of things. I mean, Jinja obviously knows, so it can probably be found, but I don't think there's a public way. Typically, you rely on documentation for knowing what you can access. And if you try something that doesn't exist, you get an error. So you'll find out soon enough.
Would you recommend
Uh, I think what I recommend is don't rely on functions that much. You can call, so instead of passing a function to the template, you can call the function here and then pass the result as a variable. And that makes the template simpler. It really, I mean, this whole idea of separating logic, which is this, versus presentation, which is the template, is that they're separate. So the more logic you put in the template side, the more they couple together, and that's not good. So I would recommend, my recommendation is that you run all your logic in your code, and then pass all the digested results into the template. In your Python scripts, you will probably have more than one file when you have a big application. So you may need to call functions that are in other modules, but do it all while you are running the logic before you call render template. That's the best way to keep things separate. And besides, if you put too much logic in the template, if you have, if a designer, a different person is working on the template, you risk, there's more risk that they're going to mess it up because they're not going to understand that. So the simpler you keep it, the better. Okay? So, okay, so I think we'll have 15 more minutes till the break. I'm going to start with this. Or unless you want to, do you want to break now and we do web forums after? Yes. And then I get to help the ladies here. Okay. Let's take a 20-minute, I think it's 20 minutes. Okay. So this is going to start to be a little bit more involved. So if there are any remaining questions from either the basic application structure or templates, this is the time. Okay. So web forms, this is a HTML or I guess HTML, HTTP. This is a way you can have users provide information. So you put a HTML form in your page, and when the user completes those fields and press the submit button, the browser sends a special request to the server, which is different from the other requests that we've seen before. The other requests, basically the browser asks the server for content. When you have a form, the browser is sending content to the server. It goes the other direction, okay? The requests have names, or they're called request methods. The request the type that we've seen before, where the browser requests a page, they're called GET requests. The requests that submit data, they're called POST requests. And we're going to see how those are handled. So version 06 is the one that will introduce a little form. And the form that I'm going to add is the form that asks yes or no in the question page. So let's take a look at that. Let's ignore this and let's go to the template first. So this is all straight HTML. There's no Flask in here. In HTML, you define a form like that. You create a form element. I'm telling it to use a post request to submit the data. You can, I said that get requests, get data, and post requests, submit data. There's a way to to use get requests and submit data at the same time. So, and for some reason that's the default. So if you, when you create a form, you don't say method post, it will use a get request to send the data, and that's awful. And I mean, I can tell you why if you want to know, but I don't want to get carried away with something that's unrelated to Flask. But you know, if we have time and you want to ask me, we can talk about that. Anyway, every time I create a form, I set it to use post requests for submitting the data. And then I have these two input elements here are the yes, no radio buttons that you saw when I did the demonstration. And these have the name of the field, the name I'm going to use in Flask is answer, and it can be, the value could be yes or no. And you're going to see how we get this in a moment. And this is a label, so this is what's going to be displayed in the page for each of the buttons. Finally, we have a submit button, and this is the one you click to send the data. So let's look at the application now. On the question route, I'm importing a new, this is here, request, a new symbol from Flask. It's called request. Request is an object that represents the request that the client made. So you are going to use it to get a lot of information about the client. So if you want to know, for example, the IP address of the client, that's there, and a number of other things. Among them, you can ask which method was used to submit that request. So if the browser send a GET request, that's going to be GET, a string, that is GET. If the client sent a POST request, it's going to be POST. So this is a way, a nice way, nice and easy way to determine if you need to provide data or you're receiving data. If request is POST, you know that there's data coming to you in the server. So basically, oh, I'm sorry, I forgot one more thing. When I define the route, the default is the route to be connected to GET requests only. So now I need to tell it that I also want POST requests to come to this function. And Flask does it this way because in many cases, you want the GET requests and POST requests to the same URL to be handled by different functions. And you can do it that way. So you can say, you can leave this one the way it is, and then add another route with a different function name, and say methods equals POST. And then you have them separate. So that's not something that I do with web forms. I do it all the time with APIs. For APIs, I want them separate because they're different enough. GET requests and POST requests in an API are very different. But they're not so different here. So in this one, I'm just doing both with the same function. Okay? So inside this function, I have two cases. If I have a GET request, I need to render the form. That's all I need to do. So this is going to be false. So I just render as before. If I get a POST request, I have this request.form dictionary with the data from the form. So I can use that in my logic. So request form answer, remember that answer was the name of those two radio buttons. So answer is going to be either yes or no here. And that's how I know what the user selected. So remember what I told you, that there are so many things that you need to build when you're starting up, that if you try to do all of them, basically you achieve nothing, right? So here's another one. We don't have a game logic yet. So, I mean, we know the user say yes or no, but we have nothing to do with those yeses or no, or no's. So for now, again, this is a fake logic that we are going to replace with a real thing. For now, I'm going to say that if the user says yes, I'm going to go to the next question. And if the user says no, I'm going to stay on the same question. So if the answer is yes, I do a redirect. This is a new thing. In this case, if this says yes, I want to go to another page. So the two options that I have is to just render the new page here, or better, to issue a redirect. And this is a special type of response. If you respond with the redirect, inside I'm using URL4 to generate a new URL. And that basically changes the URL in the top of your browser to the new one. So it's like clicking a link, but you from the server are generating the click in a way. Does that make sense? So I say URL4 for question with the next ID. So whatever ID came here plus 1. And then I put that in a redirect response. Redirect, by the way, is here. I'm importing it from Flask. It's a Flask function. Okay, and this will basically send the browser to the next question. Something that I think I didn't mention before. So far, we've seen URL4 used in templates. But URL4, you can import it into your script and use it in Python as well. It works exactly in the same way. It's actually the same function that you use in the template. So here I'm using it for generating a URL in my code. And again, this is so that I don't have to type the URL in two places. I have it in one place. So are there any questions with this simple logic? Yes?
When redirect happens, does the information in the request.tone still exist?
After you come back from the redirect? No, that goes away. That's actually a very important question. So he asked if request.form remains loaded with the data after you do a redirect, and the answer is no. No, that only exists in the context of the post request. But as soon as you do a redirect, the redirect will get you back into this function as a get request, and that doesn't carry any data, so you lost it. And we're going to see how to save it. So that's coming. So don't worry about that for now. So let's go take a look at this. Let's run it. So as you see, this is starting to take shape, even though we still don't have logic. So if I say begin, I click that link, I get to the first question, and here I can say yes or no. If I say yes, it goes to the next question. I have no more questions, so if I say yes again, this is going to break. We're going to fix that. And if I say no, it stays in the same question. But at least now we have a way in the server to get data from the user, which is the important thing. So this is another thing that I think it's important to mention. So let me show you here. Note that if the user says no, if the user says yes, I do a redirect. If the user says no, I didn't do a redirect. The logic falls down into the render template, and that's how I get the same question. Okay? So take a look, see what happens. I'm going to say no. So I get the same question. And what happens if I do a refresh? Have you seen this before in browsers? So if you're not, I mean, if you're used to do refresh a lot, and chances is you've seen it. It's super confusing. I mean, if you ask me to explain this, I can't, honestly, because it's so confusing, right? So we want to avoid, and all browsers have this, a version of this. This is one of the worst in Firefox. But you have to avoid, when you work with forms, this happens when you use forms, and I can explain why in a minute. We have to avoid this because this confuses users. The problem is that it's because the way the refresh button works in browsers. Basically, when you do a refresh, the browser does is it sends the last request it sent again. So if you go to facebook.com, you get the page, you say refresh, it requests facebook.com again, and that's how it refreshes the page. So if the last thing the browser did was a post request, it will try to issue that post request again. But post requests send data. So the browser wants to make sure that you know that it's going to have to send that data again to refresh the request. And it puts this awful warning that I'd say 90% of the users will not understand anyway, right? And then they're lost. They don't understand what to do. Okay? So the way to avoid this in your applications is to always respond with a redirect when you do a form. So when you're handling a form, so you get a post request, you need to make sure that the last thing the browser ever waits for user input on is on a GET request. So you get a post request, you do whatever you need to do to handle it, but end it with a redirect so that the browser then issues a GET request. And then the last thing is a GET request, and it can be refreshed. Does that make sense? So I did that in 0.7. Basically, all I did is just handle the no case by also sending a redirect to the same ID. I mean, really, this is not necessary. We could let it fall through to the render template, but then you get that behavior that you should always try to avoid because no user will understand how to handle that. And I mean, this is so well known that it has a name. It's called the post redirect get pattern. So you should keep that in mind. Remember in the beginning, I mentioned that anything you get from the user needs to be validated, that the users are untrusted, that you should never trust what users give you. So Flask doesn't do a lot to help. This is an area where Flask doesn't really help a lot. Flask is really nice wrapper around the HTTP protocol, so you don't have to deal with the bare bones HTTP, but it doesn't do much in terms of validating user input. So I find that insufficient. Validating forms is something that is it's pretty much the same on every project because forms are pretty standardized. You basically just need to add validation rules and then make sure that they're valid, that you run them and that the rules say that the input is okay. But Flask doesn't do that, and I mean, if I had to do it myself, I will have to repeat the same code over and over because validating forms is not rocket science. So this is one case. I tend to do things by myself a lot. Usually, if something I can do, I do it myself versus getting a third-party package. But this is a case where I break that rule, I guess. Validating forms is super boring and tedious. So there's one package that does a wonderful work at this, and it's called Witty Forms. And I use that all the time. So if there's one go-to extension that I always use in my Flask projects, which I don't really use a lot of extensions, but this is probably the main one uh, because it's super useful. So Witty Forms, it's not a Flask-specific project. It can validate forms for any framework. But then there's an extension that makes it a little bit friendlier to Flask. That's called Flask WTF, which is a name that I love. I didn't, you know. Anyway, we can say Flask Witty Forms, I guess, to be more correct. Hmm? So anyway, version 0.8 is the one that implements this, and this one is there are a number of changes here, and I need to make sure I remember all of them. So Witty Forms does a number of things. You're going to get scared when you look at the code. There's a lot of changes here. I'll try to go through all of them. So one thing that, one of the many things that Witty Forms does is it protects you against CSRF attacks. I don't know if you know what that is. Basically, any application that accepts forms, the regular workflow is you go to the page, send a GET request, and that renders the form, and then you type your data and submit. That sends the POST request. So nothing prevents an attacker to just send a POST request, skipping the GET request, and just send POST request with data. Okay? An attacker or you can do it too. But this is a something that attackers exploit. So if you are, let's say you are logged in to your bank, so you have a cookie there, so you don't have to log in every time. Banks don't do this, but just for the sake of an example, let's say you're logged in, so you don't have to log in every time. There's a cookie that remembers you. You can have an attacker running in JavaScript in your browser, send a POST request to the bank with a transfer of money. And since you have a cookie that tells the bank that you're logged in, you send the POST request, the bank will take it. The bank will think it's you. So that's called CSRF attack. So Witty Forms protects you against that. And the way it protects you against that is by ensuring that the GET request that is issued to render the form is issued, that exists. It puts a token, basically a random string of characters, that's every time it's different, in the form. That's in the GET request when you render the form. And then when you submit the form, that token goes back to the server and the server verifies it. Okay? So in the example of the bank, if you just send a POST request, you don't know the token because you didn't get the form. You need to get the form to get the token so that then you can submit the form with the valid token. And that's how they prevent the CSRF attack. Now you can say, well, okay, the attacker can go get the form, find the token, and send the POST request. But browsers prevent JavaScript from sending GET requests to cross domains. So, it's I guess it's possible, but much harder. So basically, this is one of the things that Witty Forms does for you. To be able to achieve this, it generates these tokens that should be hard to guess. And the way it does that is by using a cryptographic key that you need to set, and it should be different for every application. So all this long talk just to explain this line. So that we can do CSRF protection, we need to set up a secret key in our application. And Flask has a config member, which functions as a dictionary, where you can set configuration values for Flask itself or for extensions. They all use this app.config object. So here I'm just setting a string as a secret key. And then Witty Forms will, or I should say Flask WTF, is the one that does this. Flask WTF grabs the secret key and then gives it to WD Forms to generate these tokens. And of course, the secret key needs to be secret. If it's not secret, then that means that the attacker can generate tokens as well. So we don't want that. Okay? So this should be, typically when I do a real application, I don't even put it here. I just put it in an environment variable, which is how I write sensitive information. Put it in an environment variable, and I get it here from the environment, so that it's not in the code. Okay, that will be the best way to do it for a real deployment. So okay, we have a secret key. Another thing that Flask WTF does is render the forms for you. If you remember the previous version that I showed you, I had all the HTML for the form. I typed it myself. So you don't have to do that. If you don't want to render the fields, all the fields one by yourself, you can use facilities provided by WD Forms to do that. And the way that works is that instead of writing the form in HTML, you write it in code. So we have this form class, this form class, which we get from the extension, and then we can create a subclass of it defining the fields of our form. So this is the yes-no form that we had before. This is the WD Forms version. So I just create a class yes-no question form with two fields, and the fields are class variables. When I was learning Python years ago, this seemed like a pretty strange syntax. I didn't know this back then. These are defining class variables. That's the way. It sounded like this was code inside a class. It made no sense to me. But this is the syntax how you define a class variable, which is the way WD Forms takes the fields. So WDForms.fields is a package that has classes to represent all the possible form fields or form field types that you can have. So here I'm using the radio field and the submit field for this form. And you have a label. For the radio field, you give the choices as a list of pairs, and each pair has the internal value and the label. So yes, lowercase is the value that we check against in our code, and yes, uppercase is the label. And you need a label because we are going to use this to render the field. We're going to remove all that form code that I had and use this to render. And the reason, once again, is to remove duplication. We want things to be in one place, same as with the URLs. So this one, the submit field only takes a label. That's the label that's going to be in the button. Okay, so we have the form. In the question route, there is the form. I create an instance out of that form object, form class. So I create the instance. Let's skip all this in the middle, and let's see how we render the form first. So in the render template, I was passing the question, the text of the question that was displayed in the form. Now I'm going to pass, I'm going to pass the form object as well. And when we go to the HTML page, I have the form heading for the form element. This is the token for the CSRF protection. You need to include this. So you don't have to worry about what this is. WD Forms takes care of generating code for you that does the CSRF protection here. And if you want to know what this is, it's a hidden field. So this is a field that's going to be in your form, but it's invisible. It will have the token that protects against the attacks. So this is, there are a couple new things here. We have a field that has two options, so that the yes and the no. Both are going to render exactly the same, and I don't really want to hard code the knowledge that I have a yes and a no. I mean, this is, I mean, here, all this is just a radio field with, you know, a few options. I don't know how many. I want to make it very generic. So I'm going to use a for loop. This is a facility provided by Jinja 2. So far, we've seen this type of syntax where we have double curly brackets, and then you insert a value inside. Jinja 2 has an array of control structures that you use with the curly bracket % marker. So you have for loops, you have conditionals, you can do if statements. I think we're going to see an if later, and a bunch of others. There's a number of things that you can do. Jinja is super powerful, so if you're interested in learning what you can do, the documentation for Jinja 2 shows you all the things you can do. There's a lot of things. So for loops work pretty much in the same way they work in code. Remember that I passed form as a template variable. So I can say form.fieldName, and that is my field object. So form.answer is my radio button object. It's just to make sure that we're on the same page, is an instance of this radio field that I called answer. Okay? So if I do a loop on that, I can iterate over the options of this field. And then for each option, I can just render the option itself, and that will trigger WIDI forms to output HTML code for the form. So you don't have to worry about doing the input, type, radio, all that stuff that we had before. WIDI forms does it for you. And option label is the label that you assign to it. So I'm going to render that as text right after. So you get the button and then the label. And down here we have the submit button, which is form.submit. That generates, again, HTML code. Anytime you do form dot and the field name, that generates the HTML for the field. Easy enough? Any questions? Okay. So we have the form, and we rendered it. So now let's look at what happens when you get the post request. So here, in the previous version, I was checking request.method to find out if it was post request, because in that case I needed to handle, to take an action on the data that the user submitted. With these form objects, you can do something better. We are going to learn how to validate the form, make sure that the user is not sending invalid data. And there's this method called form.validateOnSubmit. This is a do-it-all method that returns true if there was data submitted, in other words, that this was a post request, and the data is valid. So both things together. It returns true if there's data and the data is valid, and it returns false otherwise. So instead of checking the type of request like we had before, here what we're saying is that if the data is there and valid, I'm going to act on it. If not, I'm just going to go ahead and assume it's a GET request and render the form again. Okay? What it means for the data to be valid. So far, nothing. We haven't done anything to validate the data. So if there's data, Weedy Forms will say, yeah, it's valid, because we haven't put any constraints. We haven't specified how to validate the data yet. So for now, this is only checking that there's data. It's not going to apply any validation yet. So if we get inside this, that means that we have data to work with. And the way you work with the data is form, this is the same form object, form.fieldName.data. That gives you the data that the user typed. So you don't have to go to the request object like we did before. You can, if you want. It's still there. So you can get this data from Flask. But this is a little bit higher level. I prefer this. So you can say form.answer.data, and that will be the string, the value of the option that the user click in those radio buttons. So it will be yes or no, lowercase. So if it says yes, we haven't changed this. We still go to the next question. So fake logic still. And if it says no, we redirect to the same question. I think I covered everything on this one. So we are ready to play with our real game now. So the way I did this, I could have added the logic in this app.py file, but that would not be good. Game logic, it's completely separate to the actual web application. Maybe one day you want to have the same game as a desktop application or as a phone app or something. So really, implementing this game, it's not a web development task. Right? So what I did is I put it in a separate module. So when you go to version 0.9, you are going to get a new file, a new Python file. It's called guest.py. So now we have app.py for our web application and guest.py for the game. And when we look at this, you're going to see that there are absolutely no web references in the game logic. So I'm going to show you. See, I'm going to do it by hands, so I'm going to make mistakes, I'm sure. I'm going to show you how this works. So I'm going to import the main class of this game logic. It's called guess. And I'm going to create a game. And the way you create a game is by starting with an initial guess. So if you remember from the demo, this is a game that grows, it learns. So it starts with just one thing. So it knows, let's say, about Python. And then you play the game, and let's say you get the wrong guess, and you want to expand this. And that is done this way. You can expand Python to also include Ruby with the question. Remember that I did all this from the demo, right? It's the same thing. And the answer to these questions for Ruby, for the new language, is going to be false. So I loaded a second language now in the game. So let's say I want to play. I can say get question. So we can say true or false for yes or no. If I say true, it returns a number. This is an ID. So now I can say, basically it sends me to a different position in the game. And now I can ask a question for position 1 or ID 1. And it returns none. That means that there's no more questions. So I can say, give me the guess for 1. And the guess was Python. Does that make sense? It's basically, when I do this, really, this is a default for 0. So we have one question, and depending on the answer, so if I say answer question false, it's going to give me a different ID. And when I do say get question for 2, still doesn't have any more questions. And sorry, the guess is Ruby. So basically, this is a little engine that we can use to drive the game. I'm not sure I'm going to spend a lot of time on the actual implementation of this. I poured a lot of comments on this. In case you're interested, I see it as unrelated to the main topic of this class, right? Because this is all strict Python logic. But I put lots of comments here in case. Here you have an example where it builds a more interesting game using Python, C++, Java, and Ruby. So you have expand. We've seen that. We have the get question, which returns a question or none when the game reached the end. And at that point, you can say, give me the guess, and that will give you the final guess. And we also have the answer question, which is the one that you provide the responses from the user. And we have a private method here that's used internally. So if there's time and you're interested, we can talk about this. But for now, let's assume that this is a third-party game engine that we are going to incorporate. So I think for this one, I'm probably, let's see how that works. I'm going to go to the GitHub. This is 9. I can show you the diff view so that we can see all the changes. They're all spread on the code. I don't know if you know about this in GitHub, by the way. If you look at, and this is the way I prepare these classes, that they're all incremental. So if you want to see differences for a specific feature, you can go look at a commit, and it will show you graphically all the things that changed from the previous version, which is super useful. So I'm going to use this to make sure that I don't forget to discuss anything. So here we import the guess object. Remember those fake lists of questions and guesses? They're gone. Instead of that, we create a game and we add a couple languages just to have something to start with. So we have Python, C++, and Java. In the question, we receive an ID, so we can say, give me the question for that ID. Instead of just, we had this fake question from a list. So now we can get a real question. We can ask the game to give us a question for the given ID. This is going to be 0 in the beginning. I'm doing a little bit of validation here. For any reason, I don't get a question. I'm sorry. If I don't get a question, that means that we reached the end. So I redirect to the guess page. This is going to show the guess. And I pass the ID, because if not, it's going to be lost. Then we have the form. Here we had this fake logic. Remember that if the user said yes, we move to the next question. If the user said no, we stayed on the same question. That's all gone. Instead, we called answer question with true if the user said yes. This is going to be true if the user said yes, false if the user said no. So we answered the current question. That's our current question, the ID number for the question. We pass true or false, and we get a new ID. And then all we need to do is just go to the new question. So we redirect to this new ID that we had, that we received from the game when we answer one question. We get the ID for the next question. Or a guess if we reach the end. Finally, on the guess page, instead of using the fake guesses, now we have an ID, so we can get the real ID. I'm sorry, we can get the real guess using the ID. So we can show real data. Are there any questions about this? So when we run this, oh, I'm sorry. Wow, I forgot. Remember I said, we're looking at forms, and I said that we were going to use an extension? So none of you are running this. Nobody told me that. I forgot to tell you to install.
No, you mentioned it was in the requirements, like maybe you didn't explicitly.
I didn't mention. Yeah, it wasn't. It isn't the requirements, but I didn't mention it. Interesting. Okay. Yes. I'm sorry. To be able to use the forms, you have to install Flask WTF, which I did not here, and many of you probably received the error and were too afraid to let me know. Okay, let's try again. Oops. So now, let's go start from the beginning. If we start the game, so this is now coming from a real game, right? The game that we built with C++, Java, and Python. So if we say it's interpreted yes, that's the only guess it had. If we say no, it has another question to separate C++ from Java. So if I say yes to this, it's going to be Java. And if I say no, it should be C++. Does that make sense? So the game is now taking shape. I mean, we still have some things to do, but at least we can play it now. So the main thing that we're missing is the learning part. When the game ends, you remember this from the demo, the game asks you to confirm that the guess was correct or not, and if it was not, then you have to enter information to expand the game. So let's add that. That's version 0.10. So now we have, well, first of all, we have in the guess page, start from the easy part. The guess page was sorry. It's not going to show it to me. Anyway, if you remember the guess page would show just the guess name. It will not say anything else. So it was just, my guess is Python, for example. So we need to change that and show a question. We need to ask the user if the guess was correct or not. So for that, we are going to reuse the yes/no question form, the same form that we use during the question phase. We can put it in the guest page at the end as well, because it's the same form. We have to get a yes/no answer. So you can reuse the same class. You don't have to create a new one because the forms are identical. So yes/no question form, I created, I validate. This will tell me if I get data or if I need to present the form and wait for the data to come in a subsequent post request. If this is false, I render the template, and now I'm adding the form to that template. You can see it right here, exactly the same as what I did before. We have the CSRF protection and the fields and the submit button. If we get the data, if the user said yes, that means that we guessed, the server guessed the language, so we have nothing else to do. We can redirect to the index page, and that will begin a new game. If the user said no, then we have to go into this new page where we ask all these questions. And that page, I called it learn. So that there's a new route down here that's called learn. So I redirect to learn with the ID. Okay? So on this new page, we need to have a more interesting form. And that's the layout of that form. We have first we ask what's the language, the new language that we don't know about. Then we ask for a question that can separate this new language from the one that the server guessed. And then we have a yes/no field to know the answer to this new question for the new language, and a submit button. So new thing here is the string field. This is the basically a text box, another HTML form element that I imported here from Witty Forms. So this form goes in the learn page. It's right here. So notice that basically the workflow when you work with Flask W2F and Witty Forms is super simple. Create a form, validate on submit. Inside the if, you do the handling of the data. Outside the if, you do the rendering. And that's pretty much the same, always. So here I get what was the language that the server guessed that came as an ID in the URL. And when I get data, I call that expand function that I showed you before. So I pass the guess, which is the old language, the language that we thought was the one. This is the new one coming from the form. This is what the user typed. This is the question, and this is a true or false, which is the answer of for that question for the new language. So we expand the game, and then go back to the beginning. So not that complicated, thanks to having support for the game logic outside. We don't need to see it here, right? I mean, if we had it here, the code would be much more messy. Okay? Are there any questions about this? I guess I didn't show you the template. The template for the learn page, it's basically some text. Sorry, I did not find your language. We have the form. Always we need to have the hidden token for the CSRF protection. And then for text forms, I render the label first and then the form. the field. So I do that for the language and for the question. And then I get, I need to display the yes, no, which works in the same way as before with the for loop and the submit button. So for this, we can try the Ruby exercise. So is this interpreted yes? Is it Python no? And how I type. Oops. And the answer for Ruby will be no. So now it's incorporated, and next time you play, that question is there. So we're getting very close to the end here. Any questions?
So I can make via Flask, I can make fields programmatically in Python, or they could exist in the HTML form.
Mm-hmm.
I assume in almost all circumstances you would want to do it programmatically unless it's completely static and never going to change.
So yes, for the same reason of not having duplication, if you create the form yourself, you have to type the name. When you define the input element, you have to put a name. So that name is going to be there in the HTML, and it's going to be repeated in the code. If you do it programmatically, then you put the name in this class, the form class, and then it gets rendered from it. So it's better. So if you have control, and sometimes you don't have control. Basically, the form somebody else did it, and you cannot change it. So you create your form class, modeled after the HTML. But usually it's the other way around. I recommend that whenever you can. Yes. Other questions? So you're asking about validation, and we haven't done validation yet. So that's coming. But you were asking about the, you said the guess page? This one. So, correct. So far we don't have validation. Usually the way validation works, and we're going to see that in a minute, if the input is valid, then you carry out whatever action you need to carry out and then redirect somewhere. If the input is invalid, then you have to present the form again for the user to make a correction. And that's what we're doing next. So the token could be missing. One of these fields could be empty, for example. That's one example. And we're going to take care of all that. And we're going to take care of it now. So one more thing that WD Forms and Flask WTF excel at is validating. So that's in 0.11. So WD Forms comes with a whole array of validators for all different sorts of things that you may want to validate on form input. So we're going to start with something very simple. We're going to say that do I have that running here? No, I don't. The two fields, these two fields in the final page where you have to enter the name for the new language and a question, those two must be non-empty. That's a pretty safe assumption, right? If they're empty, if you use the 0.10 version without this, the previous one, and leave those empty, then you're going to have a broken database, right? This game logic will be all corrupted because there's going to be empty strings there. So bad things will happen. So we don't want to allow that. So we're going to use one of the validators that's called required. So that will check that a field is there and it's not submitted empty. So how do I do that? Here I have, this is the language. So before, all I did in the string field constructor was to send the label. So now I can add an optional validators and give it a list of validator objects. So for this one, I'm going to say required. So now, and I have it also on the next one, both. Okay. So now let's go to learn. This call here, which used to be pretty silly, it was pretty simple. It will check that there's data. Now, this call will also go through any validators that are attached to fields and run them. And yes. If I'm sorry, I didn't get that. The token is already validated. And actually, yeah, I didn't say that. So yes, that's a good point. It happens inside this function. But it's already happening. That we don't have to do ourselves. It's been happening all along. So the token is validated, but that's done by Flask WTF automatically. Yes, that's a good point. I should have mentioned that. So yes, this is not as simple. You're correct. This was already validating the tokens.
When you set the validator argument to required, does that mark it up on the HTML as required, so it does client-side validation?
It does not. If you want to render your fields with custom, let's say you use Bootstrap, something that gives it a nice look with CSS, you will have to add that yourself.
But how can I add it myself if I'm not entering in the form fields for HTML in the
How do you do it yourself? Let me show you. So these are things that I didn't mention here, but I can show you quickly. So let's say this one's required. So you can say here, and then that will be a CSS class that will render it in a different style. Okay. So yeah, I didn't mention this. Let's say you want to make this longer, so you can say anything you can put in the field, you can send as arguments here, and if you want to make it really long, you can do that. So you can modify the way WDForms renders your field. Yeah, I'm sorry, I should have mentioned that. Anything that is valid in the regular HTML element, you can pass here.
So if I pass in this class equals required, then the user will not be able to submit that form on the
This class equals required. This is not. There's no logic associated with it. It's a CSS name.
Okay, but there's also an HTML5 of required property that
Okay. If
will prevent.
okay, that one, then you will say. Yeah. If you want that one, then you can do that.
Okay, and then there would be no reason to do it on the back end since that form could never be submitted.
That's a very good point. So what he asked is if you validate in the client, there's no need to validate in the server. That's false. You have to. You have to revalidate in the server. Remember that thing about users not being trusted?
Okay.
You never trust. You don't know that the user is running a proper browser that is validating, right? It could be running, Internet Explorer from 1998. Who knows? So very important point. You always validate in the server, even if you validate in the client. So okay, let's restore this. And so just want to make sure I didn't forget anything here. So we have the required added here, and as I was saying before, now validate on submit will check that there's data. If there's no data, it will return false. If there's data, it will check that there's a point made by you there. It will check that there's a token and that the token is valid. If not, it'll return false. Next, it will go through all the fields and see what validators are attached to them. And it will run those validators and make sure that they return true. This is a very nice structure because those validators are just little objects that do their thing. And if you need a custom validation thing, you can write your own. It's very easy to create your own as well. So basically, Reforms, all it does is call all the validators and expect that they will say, yeah, this is okay, or no, this is invalid. But you can write your own if you need some custom need. So if all of that is true, then it will go into the expand. But if any of that is false, it will not. So I extended the template to show errors. One nice thing about these validator classes is that not only they say yay or nay, they also provide an error message when there's an error. And we want to show that. So here are the two text fields, right? So if we look to the right, so form.fieldName.errors will be a list of validation errors associated with the field name. So what I'm doing here is I'm creating another for loop, and I iterate. There could be more than one. Usually there's only one error. When something fails, you stop. But sometimes, some validator may add multiple messages. So you iterate over them. So for loop. And then for each error, I display the error text. And then I end the loop. That's it. So now we can see how this looks. So just to make sure it's start clean. Is it interpret? Yes. Is it right? No. This is something nobody asked me about this. I expected someone by now would have asked. Notice that we lost Ruby. You know why? We restarted the server. So there's no database in this application, right? The data that we build remains in the server while the server is running. If we stop it, we lost it. And this class, I'm not talking about databases. It will be too complex a topic to discuss. But if you want something, if you decide to learn databases, you could extend that game class, the guest class, to write the data and then recall it next time you run the server. So, okay. Watch this. So this is very nice, and it's almost effortless for us. I've been doing this for a few years, and it still excites me that this is so simple to do. I love this. And if I do one, I resubmit. Oh, I forgot. This one we got for free. I forgot to mention this. I missed it in the template. I'm sorry. I did it also for. So this one, it's a radio button. So the validation is implicit. You know that you need to check one or the other. So you don't have to attach a validator. It's already validating and returning errors for us. So if I show errors on this one, exactly in the same way, just a for loop, the list of errors, if I don't click the yes or the no, if I leave it unselected, then it would also show me an error there. So now that I type this one, that one's fine, but this one's not. So I can type something there, and it will still not let it go through because now the radio buttons are unselected.
So another quick question on
Yes.
client side versus server side
Mhm.
validation. Wouldn't it make sense to render the error message using JavaScript on the client side so that I don't have to make a request to the server?
Uh,
So the feedback is instantaneous rather than hitting the submit button?
Yes and no. So the question is if it will make more sense to render the error messages on the client versus having a trip to the server to validate and find the error and then render the error and then come back to the client. And the answer is yes and no. Uh, you can do it. The problem is Flask, WTF, and WIDI forms, they run on the server. So if you are in the client and you want to validate without a trip to the server, you have to use something else, a JavaScript framework. And based on what I said before, when you validate in the client, you also need to validate in the server. So you will still want to do the server validation, and if they disagree, server wins. You have to take the errors from the server and send them back.
But would it be a better user experience to do the error handling on the client just so the
Yeah,
feedback is
sure,
instantaneous?
absolutely. Yeah, it's more work. So if it really if you are conscious about saving the bandwidth and the making it more performant,
And user experience too.
yeah, user experience. If you want to validate as the user type, uh, instead of waiting until they click the submit button, absolutely, that makes total sense. But that's basically that's temporary. The real validation happens in the server and should not be removed. That's very important to not avoid that. Yes, sorry.
Does Flask do forms, does that have the ability to output JavaScript such that it will use client side or can it use
Actually, I believe when you use WIDI forms has HTML5 fields as well. I believe those have a little bit of validation on the client side. I don't play much with those. I think you get something there, but I think if you, in my experience, if you have a layout for your application, uh, I, I, I tend to do it myself just to make it, but make sure that it looks, integrated with the rest of the application's look. So there's work there. You have to do some work on the client side, unfortunately. Yep. So, okay, let's see. So I think that's all I have for forms. Now, I'm not sure, some of you probably thinking this, that this is a silly game. The numbers in those URLs, you can cheat, very easy to cheat. Yes? Do you agree? It's kind of crappy game. Not fun, right? So that was basically an excuse for me to show you how to send dynamic arguments in URLs. But this is not a good use for that technique. A good use for that technique is, as I mentioned before, I think, to show a profile page where you have a username in the URL. But for this, basically, this is information that you don't want the user to see, right? You want the user to play the game, and I don't know if you remember for the demo, you probably didn't pay attention, but the numbers were not there. Okay? So what we need for this is we need to store information about the user, the experience that the user is having with the application in a way that the user cannot see it. What we're doing now is we're using the URL as storage for user state or connection state, right? But that's, I mean, for this, it's not a good idea. So we're going to change that. What we're going to do is use this feature that comes with Flask as well. It's called user sessions. Basically, anytime a user connects to the application, Flask initializes a dictionary where you can write information about that particular user. So if you have 100 users using the application, there are 100 dictionaries, one for each user. And each time the browser sends a request, that dictionary for that user is available to you, and it's remembered from page to page. But all the users are kept separately. So that's called user session. Pretty much all frameworks, languages have it. At least web frameworks, most of them do this. So basically, the purpose is to remember the state. Very important usage for this is when you have an application that users log into, then you write the login state of the user to the user session, and that's how the user can navigate from page to page, and the web server remembers the login state. So you will use the same technique for logins, which we're not going to see in this application. So version 12 is the one. Oops. Sorry. Someone's chatting me. My son. He's going to be in the video also. Okay. Version 12. And let's take a look at this. So that's the new thing. So Flask supports this session object, and it's really easy to use. Inside any route function, when you're handling a request, you refer to session as a dictionary, and anything you write, it's remembered. Next time you can look for it, and it'll be there, and it'll be user specific. If you're interested to know how that works, if you're interested, this is Flask internals. Anything you write to this dictionary, Flask will put in a cookie, and it will send it to the client. So this will be stored in the client, in the client's web browser. It will be a cookie that is cryptographically signed to make sure that the user doesn't tamper with it, that there are no attacks possible, so that you can see what's in the cookie, but you cannot modify it. Okay? So, yes?
So it actually stores all the data in the cookies rather than having session state on the server somewhere?
By default, Flask, yes. Flask writes the data itself in the cookie, and that cookie goes to the client. What many other frameworks do by default is different. Basically, what they do is they write the data in a file or a database in the server, and then they write a cookie with the ID that identifies that data. And then they send the ID in the cookie. So Flask, by default, sends the whole data in the cookie. So there's no need to store anything in the server. There's an extension that's called, I think it's called Flask KV Session. So that extension implements what you said, which is to write the data in the server and then send an ID to the client. Yes.
Question. Does Flask support HTML local storage to write to the browser instead of the cookie?
No. Not for sessions. I mean, you could put anything you want in the template to use local storage, but yeah, Flask does not. Okay. So let's look at the changes. So main page. Remember that we had a redirect. So that was in here. So this is the main page, the first page. Here there was a link to the question page with ID 0. So now there's no ID anymore. Okay? It's just the page. We go to that page, but on the client side, on the route side, we set that same 0, we put it in the session. So we set a question set to 0. Okay? And then the user will click that link, and that will go to this page, question, which now doesn't have the ID anymore. It's only /question. I do some validation here. I want to make sure that the session has the question. This is, again, users are not trusted. We should assume the worst about them. So, I mean, it's true. I mean, there are bad users out there. So we have to assume that we get one of those. So I need to make sure that I have this question element in my session before I access it, because if not, it's going to be an error. If I don't have a question, that means that this is either an attack or someone doing funny things, someone that didn't enter the site through the main page. That could be it. So if we find that the environment is not what we expect, we really don't know. The best we can do is go to the home page. So I just redirect to index. I put some comments in this version just to, by the way, help understand all these validation things that I added. So if we have it, we can get the ID. The ID is in the session. So session question will be the ID number, which the first time it will be a 0. So now I can get the question from the game engine. Added some validation again. If for whatever reason, I'm sorry, no, this is not validation. I keep confusing this. I get the question. If the question is none, that means that we have a guess. I'm sorry. So in that case, I redirect to the guess page. We're ready to show a final guess. And then we are going to render the question, and then when we're back here on the post request with data, if everything is valid, we are going to put the new ID. So I'm going to call answer question with the data from the user, and that's going to generate a new ID for the next question. So I'm going to write that. I override the previous ID with the next one, and then I redirect again to question. So it shows the next question. So you see, this is all protected. The user, if it works a little hard, may be able to see these ID numbers because they are in a cookie. But if they change it, then the game is over. Then when we get here, if they tamper with that cookie, this is going to be false because the session will be invalid. Flask will not give us the invalid session. So this will be empty. It will be a new session. So really, this is a little bit more, foolproof now. So this is the question. When we get to the guess page, same thing. Validation. If there's no, if the session is not what we expect, we leave. We go to the home page. And if the question is there, we get it, and then the logic is pretty much the same. No changes. And then on the learn page, the nice thing about this is that we don't have to pass that ID around anymore because it's in the session. So if we need to go to the learn page, if the user, if the guess was wrong and the user wants to enter a new information, all we do now is redirect to learn without arguments because the session is still going to be there. And here I can still know. And someone, I think it was you, earlier asked about remembering things in a form. If you get form data and then you do it redirect, if you lose the data, and the answer is yes, but you can save it in the session and then you will get it. That's a pretty standard technique. So are there any questions about user sessions? So I think there's one more topic, error handling. So can you break this up? Do you have any ideas how to break it? There's still bugs, so it's breakable. I can think of two ways. Okay, I'll show you. I'm going to run. I didn't show you the version with user sessions. I should have, but I will now. I mean, the only difference is that now the numbers are not in the URL. So now these are pre-opaque URLs that are basically difficult to guess. So now you don't know how many questions. You cannot fool around by typing numbers here and figure out, what data the game has. But anyway, simple way to break it. Just put something that doesn't exist, right? I mean, you could say this is not breaking it. This is pretty standard. Though this is kind of ugly, right? If you have a nice site with the beautiful CSS, and you do this, you can get this. So it's not really nice, right? And it doesn't fit with the look of the site. So we need to fix this. There's another way to break this. What happens if I enter invalid data? Let's say I play the game, and so it guesses it's Python, and I say, no, you didn't guess. And then when I go enter the data, I type Python. So I can show you what happens in the code. In the guess.py, in the expand, so this is the expand function that we call when someone when someone provides information. I try to get the ID of the guess that the user typed, and if I don't know it, I throw an exception. Then I try to guess the ID of the new language, and if this is not none, that means that I already know about it. So that's another error, right? So this is how it looks. So I'm going to say yes here, which I write no, and here I'm going to say Python. Doesn't matter what I type, and this doesn't matter. Okay? There's an error. So I showed you this before, and I told you not to worry about it. So let's worry about this now. When you're developing and you run Flask with the Flask web server in debug mode, this is the debug equals true that we have in the app.run, then the debugger is enabled. And this is the debugger. So if you're a beginner, you've probably seen your share of errors. If you do it in the console, when you get an error, you get a stack trace, right? You get the stack trace that shows you where the error is. So this is the web-based version of that. This is basically a stack trace. It shows all the calls in the stack until the point where the error occurred. And you can see here at the bottom that's the function that generated the error. And this is my code. Right? I just showed you this. It's this line here. So that's generating this error. So I'm just going to give you a quick demo. This debugger is super awesome. So awesome that other frameworks figure out ways to use it. It's not Flask proper. This is a dependency of Flask. It's called Werkzeug. This is the package that has all the web server utilities that Flask uses. So yeah, other frameworks find ways to use this because it's super useful. So for each of the lines, so basically you see the bottom one is the one that threw the error. The one above is the one that called this line, and you can see the whole stack here, right? All the functions all the way into Flask. I mean, this is mostly Flask. So you will probably look at the lines in your code if the bug is yours, and you can open the source code here and see it here, and you can also open a console and run code. So you can look at variables. This is super useful. So I hope you get used to work with this. The problem is that if the user is doing this, we don't want this to be seen by the user, right? So let me show you what happens when you run. Oops, still getting confused with my shortcuts here. Let me show you at the bottom. Sorry, wrong file. What happens when you run without debug mode? Yes, that's correct. So I'm going to save this. Since I'm doing this, note that I modified this file and I saved it while I had the server running. So another feature of debug mode is that it restarts the server whenever there's a code change. So it restarted automatically. I'm going to stop it because the change that I made is to switch to non-debug mode. So I want to run it again in non-debug mode now. So with this version, interpret it, yes, no, Python. So you get 500 error. So Flask, when it's running in non-debug mode, whenever there's an error that it doesn't know about, it will just say, I don't know what this is about. I'm just going to send a 500 error code to the user. 500 is HTTP status error code for internal server error. Unknown problem to Flask. So same thing. I showed you the other one. This typing something that doesn't exist, you get a not found, which is 404. So all these errors, it would be nice if you could show a page that is a page of your application instead of this pre-bare error page that will not match the look of your application. So in version 0.13, which is the last one, that's what we are doing. And the good news is that in Flask, error pages are treated exactly like normal pages. The only difference, where do I have this? Did I update? Oh, I did it again. I changed this. Okay, sorry. There we go. Instead of using app.route, if you want to define a page for an error, you use app.errorHandler. And there are two ways to do this. You can create a page for an exception. So you put the exception class. This is a custom exception class that we have here. So it's this one here. It's defined up here as a custom exception. Or the other option is to use an error code. So you can put 404, and that will be the not found error. I could have done this in two functions. So one function for this and another function for this. But all these decorators, they can be chained. Same thing applies to app.route. I could associate a function with two URLs or more if I want to. It's not common, but you can do it. But for an error, all errors, I'm going to use the same page in this case. So I render template, so same thing that I do with regular pages. Render template, page name, this is the template, and then I send, this is a custom, this is a variable that I'm going to use, which is the string representation of the exception, which I get as an argument. So Flask sends me the exception. So error will be a string, and in the error page, I can now put titles, use my own layout, and then I can show the error message, and I can put a link to go to the home page. So now, if I start this again, oops. So the not found page now, I mean, still it's kind of ugly because the whole, I made a point of not doing fancy HTML in this class to not make it distracting, but at least it is my crappy HTML, not Flask's. And as a nice touch, I get a way out, which all errors should have, and I can go back to the main page. And same thing happens. I don't know if you notice, but the error oops, you don't want to do that. This is the error message. So the not found exception from Flask renders as a not found message. Actually, this is the message, sorry. 404 colon not found. And if we do the other one, I can say, so here, this message is my error message. You can see it. Where is it? Here. So the error message of the exception gets displayed. So you can incorporate those custom application-specific errors in your application. Okay.
Within the error handler decorator, can you specify a range of all?
A range of errors. So the question is if you can specify a range of errors in the decorator. The answer is no. You can chain them. You can put one all of them in separate lines. So you will end up with a long list. Another thing, I think it works. You can catch a generic exception. So all these errors are exceptions, exception classes. So you can do one for the parent class of all of them if you want. That's another option. Oh, I didn't show this. So why we're doing this? Because users find them. No matter what you do, users find errors. So you need to make sure that when there's an error, you basically you know how to handle the unexpected by showing an error page. And that's pretty much the portion of the class where we develop an application. Does anybody have a broken application? It works for everyone? Okay, good. If you're too afraid to ask, feel free to find me discreetly lately. Later, if you want help, I'll be more than happy. I'm here till Sunday, so if you find me, I'm happy to help. If you have any questions, but I think we have 10 more minutes. So if you're going to continue learning, I think this is a pretty complete list of the topics that you may want to research. And of course, I'm going to sell myself. For most of them, I've written in my blog about it. So you'll find something about all of these here and there in my blog or the book or all the stuff that I've done with O'Reilly. But anyway, databases will be very important. Really, any real application will have a database. So I'm a big fan of relational databases. I'm old, but then there's the NoSQL databases. A lot of people use them. Uh, I think there are some good uses for them, but if you want my recommendation, I think you need to learn relational to be able to use NoSQL better. That's my opinion. Uh, the way I coded this game engine, the guess.py module, will make it simple. I did it on purpose. Basically, it stores the data in a list. So if you wanted to attempt to write that to a database, that will fit well into a table, a relational table. And all this use of IDs, all of that, I thought that would be a good way to migrate it to a real database. Uh, if you have any questions, please stop me and ask me, but I'll keep going through the list. Authentication. So this is very important. We've seen sessions, so you will use the session to write the authenticated state for user. There's an extension called Flask login that is probably my second most used extension after Flask WTF. So Flask login manages the user session in terms of authentication. It writes the authentication state, so you don't have to do it by hand. It's a very useful extension. Styling. So I on purpose, I didn't want to complicate this class because I didn't know. Probably the level of HTML, CSS, JavaScript knowledge here is it varies a lot from people to people. So I didn't want to complicate things for some that may not be very familiar with this. But normally you will use a CSS framework such as Twitter Bootstrap to simplify the creation of pages with nice looks. There's an extension called Flask Bootstrap that makes it a little bit easier to incorporate Bootstrap into a Flask application. That extension is nice because it helps with rendering forms using, you asked about forms. So Flask Bootstrap renders forms using Bootstrap styles, including errors and everything. It's really, really nice. So something that you can look to use. Structure. So this is something that's very confusing. Flask is a micro framework, so it doesn't tell you anything about how to structure your application. You have to do it yourself. This idea of using a single file for the whole thing, it doesn't really work that well when you do something for real. This project that we did here is probably the limit, in my opinion. I mean, if it gets larger than this, you will probably want to break it into multiple files to keep things maintainable. So there are ways to structure applications. So you can look at the mega tutorial that I have on my blog, or the project that I have on GitHub that goes with the book, if you want to have examples. One topic that we didn't talk about here at all is APIs. APIs are much simpler than web applications. Basically, the idea with an API is that you create a web application that provides data or receives data and processes it, but it doesn't do all the web part, the HTML part. So no need to render templates, none of that. Basically, you work with machine-friendly formats, for example, JSON. So you accept data and return data in JSON format. If you're interested, on Friday I have a talk on REST APIs, Friday afternoon, I think. So you're welcome to come and learn a little bit about APIs, which ties into the next topic, the relational client applications. So typically, when you use AngularJS or Ember or React, any of those frameworks, client-side frameworks are very common these days. Basically, that takes away the need to do templates and all that stuff in the server. The client does all that. So What's left for the server to do is to accept data and return data, and maybe use a database to store that data. And that's you end up with an API that way. So these two are pretty common these days. People seem to prefer to move all the presentation logic into the client. Unit testing, there's nothing specific about unit testing with Flask. You just, use the unit test package from the library if you want, or any other that you want. One thing that Flask helps with is it provides a test client. So when you're testing Flask, you need to send requests, and this test client emulates or simulates, I should say, because it's not completely emulated. It simulates a web browser or a client, and you can send requests into the application as part of your tests. So again, my examples in the blog, in the book, there's lots of stuff about this. So you can find references, or ask me if you get lost. Logging is another important thing. Not so much when you are developing, but when you deploy your application. Remember that there was a stack trace, and we suppressed it by implementing an error handler. That's good for the user, but that's bad for you. You want the stack trace, right? So you can write a log file with any errors. So to the user, we present a pretty error page, but then log file has the errors, and then you work on them. You don't want to miss that information. That's very useful in debugging problems. So in Flask, app.logger is a logging object from the standard library, so you can log to it. You can write your logs. Errors get logged automatically, so you don't have to. What's not done automatically is to set up a destination for those logs. So by default, in production mode, or I should say non-debug mode, Flask will write to the log, but the log object is not configured to write anywhere. So you have to tell it where you want it. So it could be a file, it could be syslog, it could be emails. It's all standard Python stuff. So you have to configure it. I think I mentioned earlier that most applications have HTTP as their method of communication between client and server. But that's not the only way. There's another way that's sort of popular these days. That's called WebSocket. The problem with HTTP is that all these sender request and receiver response, it's too chatty. So if you're doing an application that is fast-paced, say a chat or some sort of real-time game, all that interaction, sending and receiving requests and responses, that's too much traffic. It makes things too slow. So WebSocket addresses that by creating a permanent connection between the client and the server. That's not closed, so you don't have to reopen it by sending new requests. And once the connection is established, then either the client or the server can send and initiate a data transfer, and it has no overhead. So one of my extensions called Flask Socket IO is an extension that helps. It makes WebSocket look a little bit like Flask. So you write socket handlers in the same way you write your route handlers, by writing functions with a decorator. So feel free to look at that if you're interested. And deployment, we haven't looked at that at all. So normally you will not deploy by setting debug to false. That's not sufficient. The web server that we are using here in this class, even with debug equals false, it's not good for production. It can handle one client at a time. It's pretty slow. It's written in Python. A web server should be written in native code to be efficient. So I don't recommend it at all. Quick tests, fine, but if not, you're going to be looking at a web server such as Nginx or Unicorn is also pretty good, even though it's also written in Python. It's pretty efficient, so it's nicely efficient Python. Nginx, Unicorn, Whiskey will be another one, which is also a good recommendation. And again, if you need instructions to how to set up, I have it in the blog. So I think it's just the time to end, but if you have any questions, I think we have a few minutes. Questions about any of this or anything at all? Yes? Yes. So I don't have it listed here as a specific thing, but it's part of the structure for large applications. Blueprints are a feature of Flask that helps with creating portions of your application that are separate, that you can separate from the rest and make them reusable, or at least isolate them from, for different parts, from the other parts of the application. So blueprints are very useful. Basically, a blueprint is you can take a group of routes and put them in a blueprint. So instead of saying app.route when you define the mapping, you will say blueprint name.route. And basically those will be kept separate, and basically it helps you organize your application better. So if you look at the mega tutorial that I have in the blog, that is 3 years old. It was done before blueprints existed. So that one doesn't have blueprints. The application that I have in the book uses blueprints, and it makes things a little bit better organized. So if you, on GitHub, you can look at this application called Flasky, which is the application that I feature in the book. And that one shows how to use blueprints. Anything else? I'm hoping with this introduction, you now feel like you can attempt something a little bit more involved. Maybe my tutorial from last year, which is on YouTube, which was in intermediate level. So you can look at that. I cover blueprints there too, by the way. So that one was kind of this similar structure, but it was a more advanced example. So I don't know. Hopefully you can continue learning, looking at that. I mean, all these options. Thank you.